So, very good evening to one and all present here. So, right now we are in unit number 4 in material science and metallurgy. So, day before yesterday, we have started a tensile test basic fundamentals in unit 4. So, first we have begun our idea, the concept discussion. What is meant by testing for mechanical materials? Why this thing is very important? Why we have to go for uh, testing of materials, and what are the different types of testing for materials, say destructive testing and non-destructive testing. Then we carried our discussion aligned towards universal tensile test concepts. Now today we are in next classification of testing for materials, say compression test. So in the meanwhile, I also shared some documentary video on compression test in your official class group in today morning. So if you go through the video presentation about the compression test for various materials like cement, concrete, ceramics materials, as well as metallic materials. So you can come to know how far the compression tests are different with respect to the mechanism wise, apart from the tension test. And this graphical illustration gives you an idea, a general idea about the mission setup of compression test. Here, this is the specimen, the sample piece used for doing the compression test. So first of all, what do you mean by a compression force? So the compression force is nothing but the pressure which is applied to squeeze the object towards the inward direction, whereas a tension which will try to elongate the object by applying the pressure towards the outward direction. So these are the two peculiar differences between tension and compression as per the graphical illustration diagram which is presented here. So now straight away we will move on to the compression test concept. So this slide tells about the positioning of specimen into the compression test machine. So this is the test sample which is held vertically in between the two measuring heads. So the compression test is one of the inspection process which is supposed to be carried out to study the material behavior by applying uniaxial compressive stress. That is, uniaxial means that one direction the load is applied along the axis of the specimen, and the applied load should be kept uniformly distributed across all section such that equal transmission of load will be passed to the test sample. So the deformation of the test sample will be undergone very safely without causing any buckling effect. So normally the shape of the specimen commonly used for doing the compression test, cube as well as cylindrical shaped specimen. And this slide which tells about the plastic deformation mechanism of the compressive test materials used for performing on while measuring the compression stress by considering various mechanical factors like yield stress, compression strength, elastic modulus, and so on. So these factors are to be tested using stress strain curve. And this is the graph which tells about the relationship between stress strain curve for the compression test. So the graph which has been shown here, the first phase is supposed to be elastic deformation. So when the material deforms within the yield point, it behaves elastic manner. When it crosses above the yield point, the material begins to deform plastically without regaining its original shape, even after the removal of the load. So this is a different stage of plastic deformation of the raw material in the compression test machine. So as like tensile test, the compression test is also be conducted integrated manner on UTM machine. So in compression test, the piece of material is subjected to end loading at both sides. As a result, that lead to crushing action. So you can see here from this picture, both the ends of the specimen are subject to end-to-end loading condition. So as a result, the edge of the specimen experiences the crushing stress due to compression. Whereas in tensile test, the specimen elongates in direction parallel along the axis of the applied load. So these are some of the other the pairwise combination between tension and compression test. And here we can able to limit the length of the specimen in compression test. Why means in order to avoid the column buckling. If buckling takes place, so sometimes the specimen may break due to wrong the placement of the load acting on the surface of the material. So we want to have uniform stress throughout the area of the material. So we have to reduce the length of the specimen. Say for example, L by D ratio, say for a cylindrical specimen. So if you want to avoid bending for specimen, for compression test specimen, so we can put L by D ratio is equal to 10 commonly. That means length of the specimen should be 10 mm. Diameter of the specimen should also be equally 10 mm. So by restricting the length, we can prevent the bending of the compression test specimen, and we can able to carry the load very safely over the flat and perpendicular to the axis of the sample. See, by reducing the length of the specimen, we can able to apply the perpendicular load along the axis of the specimen on the flat surface without causing any bending effect. So here comes the standard size of the compression test specimen. Say 25 mm diameter. If it is a cylindrical sample specimen, so diameter should be 24 mm and the length also same value 25 mm. So consider the cylindrical specimen loaded between the two ends of the loading head. Now our objective is to find what is the compression load from the measurement scale by allowing the loading heads to compress the material that will lead to have crushing of specimen. So in return, we can also find out the crushing stress due to compression. Even though compression test ranks very low importance as compared to tensile test, because compression test is performed very rare only for few materials like plastics, ceramics, etc. What are the limitations of compression test? So this can be demonstrated here with the help of illustrative diagram. Say you consider the problem of eccentricity. So in compression test, we need to apply the load along the axis of the sample specimen. So eccentricity, the problem should be avoided. And the other one, the length, if it is a slender object, so we need to restrict the length of the specimen, as I told you in the previous slide. Sometimes the long samples will not carry equal load. That will lead to uneven measure of the results at the end of the experiment. And this picture tells about the compression test on a concrete cubical part. This is for your reference, which is displayed here. And what are the general procedure to be carried out for the compression test? So these are some of the do's and don'ts as given in the pictorial representation. See, always we must have spherical bearing loading heads. So if you don't have the spherical bearing loading head, so the applied load over the specimen surface will not be distributed evenly or uniformly. You see the first figure. So here the load is applied at one particular sharp point. So in this case, only at the concentrated edge, the amount of stress will be maximum, whereas the other end, it will be comparatively minimum. But here, by changing the design using spherical loading blocks, so we can able to surpass the deviation of uneven distribution of stresses. That is one advantage. And at the same time, we can able to gripen the two bearing the loading blocks such that the specimen position cannot be disturbed while doing the experimental process. And these are some of the dimensions for different specimen, L/D ratio. So for a long specimen, we can give 8 to 10 L/D ratio, 8 to 10 mm. And for medium size specimen, it can be of L/D equal to 3 mm to obtain the compressive strength of metals. And for a short size specimen, L/D ratio restricted to 0.9 mm in order to measure the bearing strength as well as the friction between the two loading heads. So with this, I conclude that the tension and compression both are considered to be one of the most important, the basic test measures to be carried out for the materials. So the tension, which tries to measure the elasticity by measuring the yield strength, whereas compression is more suited for brittle materials. So with this, I end my today's lecture. In the next meeting, we will discuss about the impact test, so under which there are two methods, Izod and Charpy. This thing we will discuss in the next meeting. So thank you very much. So we will see in the other occasion. Thank you one and all.